Hey everybody, so we're going to be talking about transformations, and we've already kind of discussed this in class, but really want to talk about this in comparison to vertex form. You want to recall that our quadratic parent function was y equals x squared. This is the basic function that we are moving when we're applying transformations. You'll also want to recall standard form, which is y equals ax squared plus bx plus c. And this is similar to what we were doing with the axis of symmetry and finding the vertex when we were in quadratic form. And this is standard form of that. Typically, when you're doing transformations, you're going to get vertex form, which is y equals a times x minus h squared plus k. You'll also see it written as the same thing, but it's starting with f of x. Any of these can actually start with f of x at the beginning. And this is going to be a very old school PowerPoint, and that the next slide is definitely a different paper. I'm going to go ahead and keep our vertex form on here just for these first two. Now, when you're looking at the vertex and the transformations applied, you'll want to recall that your vertex in vertex form are simply the points h and k, and that h is always flipped. Okay, so I'm going to go ahead and find my vertex. And I look at this right here. It says a -3 for my h, but that means that it's really a +3. Your k, remember, always stays the same. H flips, k stays the same. So you've got just a +4 for this. Typically, writing out our vertex will also help us dramatically with figuring out what transformations are being applied. When you're looking at the transformations that are being applied, you want to work from left to right, just like we're reading in English. So your first thing that you see is that scale factor of 1/3, which means that there's either a vertical stretch or compression happening. And because this is between, your A value is between 0 and 1, it's going to be an actual vertical compression. Next up, notice we move to the right 3 and up 4. If you want to look at what the actual terminology is, then another way that you would see it is horizontal shift. And you would say horizontal shift to the right 3. And for this one, it would be a vertical shift up 4. And so let's go ahead and do this next one. Now, you'll recall that when we set up our vertex, we didn't look at our scale factor outside. That does not change our vertex. So we've got our vertex. Your h always flips, so this becomes a -4, and your k stays the same. Looking at this right here, my a value is actually greater than 1, so this is actually going to be a vertical stretch. Oops, by 2. Next up, I can tell that I moved left 1 and then down, left 4 and down 1. You've got your x value of a -4 for your vertex, which means you're going to the left 4, and then you're going down 1. I want you to go ahead and do these, and then you can go ahead and check back and see if you get it correct. All right, so you've gone ahead and done these. And if I write out my vertex for this, I'm going to get a -2. And because there's no k value here, it's really just saying plus 0, which means it's really a -2, 0. And the only transformation that's been applied is that it's been a horizontal shift, and it's moving to the left 2. Similar things are happening on this one. Right here, there's nothing inside the parentheses, nothing that's being squared except for that x value. So then your h value in this situation is just a 0, but your k value is an 8. And that means you've only had a vertical shift of up 8. And if you were to plug this equation into your calculator as well as your parent function right here, then you would be able to see that this function has actually been moved up 8 spaces. And that's true for any of these functions. So that was a quick review of what we've been doing. Now what we're going to do is we have been given the vertex, and we've been given a point, and we have to write the equation in vertex form and in standard form. The first thing that we're going to do is vertex form only. So, and if you want to maybe make some notes up here, remembering that your vertex form is y equals a times x minus h squared plus k, and standard form is y equals ax squared plus bx plus c. You'll also want to remember that because we're in vertex form, our vertex values that we use are h and k, and the point, well, that's just going to be x and y. So I've gone ahead and labeled mine. That typically helps me. And what's going to end up happening is, you guys are hopefully using pencil. This will be a little bit easier, so watch this one. I'm going to write out my vertex form. And it says, plug the vertex point into h and k of vertex form. So this h right here is a +2, so I'm going to replace it with that 2 right there. And that k becomes a 4. So I'm just going to rewrite everything just so you guys are able to see a little bit better. Okay, now I'm going to use the other point to plug in x and y. So this y right here is going to change to the 6. Oops, sorry, and that x right there should be a 3. Sorry guys, I'm playing like juggling with all the colors in my hands. The only thing that you have to do now is simplify and solve for a. So this goes and takes us back to chapter 1 of when we were solving equations. So you've got 6 equals a times 3 minus 2 squared plus 4. Some of you have already noticed that that's just going to simplify to 1. 6 equals a times 1 squared plus 4. Again, simplifying. 6 equals a times 1, because 1 squared is just 1. 1a, we don't really write that, so it's going to be 6 equals a plus 4. Subtract 4 on both sides. You get a is equal to 2. Now that you have your a value, you can go ahead and write your basic form of vertex. So if I have y equals a times x minus h squared plus k, again vertex form, which is going to be on your formula chart. So we can go ahead and replace our a now with a 2. We already had our h of a +2, so remember that 2 flip signs, and your k was a +4. So you get y equals 2 times x minus 2 squared plus 4. And that's what your equation would look like in vertex form. You're going to need this vertex form to write it in standard form. And this is just a review of what all we've done in the last 2 chapters. Everything that you do in quadratics relates back to polynomials. So I'm going to go ahead and rewrite it really quickly. And we had y equals 2 times x minus 2 squared plus 4. Because we're going from vertex to standard. And this is just going to be using your basic order of operations, which is PEMDAS. Well, sorry for the ugly S. Now, if we look within the parentheses, there's nothing right here that we can simplify because x and 2 are not like terms. So we're going to go ahead and apply our exponent. When we apply our exponent, we have x minus 2 squared, which remember, you're going to have to expand until you understand. And now you get to FOIL or box, which is something that most of you actually really like to do. And when I go ahead and FOIL it out, first, outer, inner, last, I get x squared minus 4x plus 4. And you can always do that scratch work to the side if you still need to. We've got y equals now 2 times x squared minus 4x plus 4, and bring this plus 4 down. Do not forget to bring that plus 4 down. It's super important. Now we're going to go ahead and multiply or divide, and in this case we have to multiply. We're going to distribute this out, and we have to distribute it to each and every single one. Essentially, this is our GCF that we're now factoring it back in. So we get y equals 2 times 1 is 2, 2 times negative 4 is negative 8, 2 times positive 4 is a positive 8, and then you bring down your plus 4. Your final step right here is going to be to add or subtract, and it's going to be combining your like terms. So the only like terms that I see are this positive 8 and this positive 4. These two are not like terms, so I'm going to go ahead and bring everything else down. And 8 plus 4 gives you 12. So this is what your function would be in standard form. Thank you all for watching. Go ahead and double check, and if you put both of these into your calculator, if you go on desmos.com, and I'll go ahead and put the link in right now, you can actually see that both of these functions right here are the exact same, and they look the exact same. Thanks again.